In this video, we are going to look at another application problem, but this time we are not given the graph. So we have to actually create the graph from the information that's given in the problem. So let's look at the example. Here we have a group of students who is tracking Miss Cowie, who is riding a Ferris wheel. They know that Miss Cowie reaches a maximum height of 70 meters at 1 minute after they start tracking. She then reaches a minimum height of 10 meters at 3 minutes. We are then asked to develop an equation that models the situation. We need to sketch the graph first before we find the equation because we don't have information directly to find the A, B, H, and V values. All we have is the maximum and minimum points. So our grid is height in meters of Miss Cowie versus the time. The first point we are given is 70 meters at 1 minute. So at 1 minute, we're going to plot a point at 70 meters. Then we are told that Miss Cowie reaches a minimum height of 10 meters at 3 minutes. So at 3 minutes, Miss Cowie's at 10 meters. So just by having the maximum and the minimum points, as well as knowing that Miss Cowie's on a Ferris wheel, meaning that it rotates at the same speed, so it is a periodic motion, so it can be modeled with a sinusoidal function. So you can use that repetitive pattern to draw the sinusoidal curve. So we know that after a minute, Miss Cowie is at the maximum. 2 minutes later, she's at the minimum. So that means it's going to take another 2 minutes for Miss Cowie to reach that maximum again. So at 5 minutes into the ride, Miss Cowie will again be at 70 meters. And then 2 minutes after that, Miss Cowie is going to be back at the minimum. So at 7 minutes, Miss Cowie is going to be at 10 meters above the ground. So remember when we graphed sinusoidal functions, we always had 5 points for one cycle. So we had the maximum, the minimum, and we also had the points on the midline. So let's try to identify where the midline is. So here, the minimum's at 10, the maximum's at 70, so in between that is 40. So we can just sketch the midline, which is when the height is equal to 40. So now we can plot points along that midline. We know that it takes 2 minutes to reach the maximum to the minimum, so that means it's going to take 1 minute to go from the maximum to the midline. So we know at 2 minutes, Miss Cowie will be at that midline, 40 meters above the ground. So we can plot that point. And then Miss Cowie reaches the minimum, the bottom of the Ferris wheel, and then she starts going back up the Ferris wheel. Again, it takes 2 minutes to go from a minimum to a maximum, so it's going to take 1 minute to go in between, which is that midline point. So we now have the 5 points that create that first cycle. And then we can continue the pattern. So at 6 minutes, again, Miss Cowie will be on the midline, and again at 8 minutes. And also, if you look at the beginning, Miss Cowie is the maximum at 1 minute into the ride. So at 0 minutes, she's going to be on that midline as well. So we actually know the starting position of Miss Cowie is on the midline. So now we have enough points to draw the curve. It is always good to stop and make sure you understand the function that you just drew. So here, Miss Cowie starts on the midline, but remember that's not when she got on the Ferris wheel. It's not usual for you to climb up to the middle of the Ferris wheel to get on. Usually you're starting at the minimum, at the bottom of the Ferris wheel. But here, that's where the students started tracking Miss Cowie. So she was already on the ride before they started tracking her and used their stopwatch to see how long it takes her to go up and down the Ferris wheel. Then she reaches a maximum height of 70 meters. That's the height above the ground. And the minimum height is 10, and that's because the Ferris wheel has to be above the ground. It doesn't hit the ground, so that's why the minimum height of Miss Cowie is not 0, because she's always going to be above the ground, even at the bottom of the Ferris wheel. So if you think about a Ferris wheel, it's circular. So between the minimum, the bottom of the Ferris wheel, and the top of the Ferris wheel, there is 60 meters. So that would actually be the diameter of the Ferris wheel. And so the radius would be half of that, would be 30. So if you notice, that's the amplitude of this graph. So the radius is actually 30. And in some word problems, they might word this a little bit differently. They might just tell you the minimum value and then say that the amplitude is 30. So if you know the amplitude is 30, then you would know where the Ferris wheel would meet the midline. And then another 30 meters above that would be where the Ferris wheel is at a maximum. So now let's find the equation of the sinusoidal function using the key properties of this curve. So first, let's find the v value. If you remember, the v value is the midline. We've already identified the midline. That occurs between the maximum and the minimum, and that was when the height is equal to 40. So we can just say that the midline is when the height is 40 meters. You could also use the formula v equals max plus min divided by 2. It's the average of the minimum and the maximum. To find the average, you add them together and divide how many there are. So here, the v is 70 plus the 10 divided by 2, which again is 40. Sometimes it's easier to use the graph to find the midline, and sometimes it will be easier to use the equation. The equation is usually easier if there are decimals being used in this situation. Next, the amplitude. So the amplitude is always positive, which is why it's in the absolute value bars, and it is the distance between the maximum and the midline, which will be the same as the distance between the minimum and the midline. So here we can see that that is 30 meters. So the amplitude is 30 meters. The equation, if you want to use the equation, is the maximum take away the minimum divided by 2. The maximum take away the minimum is the distance between the maximum and the minimum, and the amplitude is half of that, which is why we divide by 2. So here we're going to do 70 take away 10 divided by 2. So the amplitude is 30. Remember, in the equation, we want the A value, which can be positive or negative, and we will decide that once we decide what the H value is going to be, what our starting point is going to be. But before we do that, we want to find the B value. So the B value, we take 360 and divide it by the period. So we're going to have to get the period from the graph. So choose 2 points on the graph. This point, this maximum point here, is an easy point, and then to the other maximum. We can see that that takes 4 minutes. So what we're going to do is take B, 360 divided by 4, so the B value is 90. So as the period is 4 minutes, that means in 360 minutes, the Ferris wheel will rotate 90 times. Now let's find the H value, the phase shift. To do that, we choose a starting point. Well, there's a very clear starting point here on the midline. Whenever you start on the midline, whether you go up or down from the midline, you are going to choose a sine function. So here we will choose a sine function, and A is going to be positive because we're moving up above to a maximum above that midline. So H is equal to 0. And then because we start at the midline, go up to a maximum, down to the minimum, back to the midline, A is greater than 0. So therefore, the equation is height is equal to positive 30 sine 90t plus 40. So make sure you're using the correct variables, h instead of y and t instead of x, because we have height versus time. Just quickly, let's look at what we could do if we had wanted to model with a cosine function. You could start at this maximum, which occurs when the time is 1. So we have an h value of positive 1. So then you would model it with h equals positive 30 again, because you're starting at a maximum. And then it would be cos this time, brackets 90, bracket t minus 1, and brackets plus 40. So here you would have a phase shift 1 to the right. If you had decided to start at this minimum, which is pretty far from the origin, so usually that doesn't happen, but if you do start at a minimum, now you would be choosing a cosine function, but the A value would be negative because you're starting at a minimum. The rest of the video, we are now going to use this equation first to find the height given a time, and then to find the time or times given a height. We have seen this in a previous video. I am going to do it again just to help students who need to see another example, as this can be challenging. But if you feel confident with using this equation, don't feel that you need to keep watching this video. So in part A, we are asked to determine Miss Cowie's height at 3.5 minutes. So we are finding h given the time. So we are going to substitute in this time of 3.5 in for t. So we get h is equal to 30. And then I'm just going to do brackets, 90 times 3.5 plus 40, just to make sure that you're finding sine of 90 times 3.5. This will depend on your calculator if you need the brackets or not. So then you get h equals 30 sine of 315 plus 40. And then just put that all into your calculator. And actually, you could have put that second line into your calculator. You can just sub in and then go. So you should get 18.8. So Miss Cowie is 18.8 meters high at 3.5 minutes. So now if you go back to the graph and you look at 3.5 minutes and you go up to your curve, looks to be about 20. So yeah, 18.8 makes sense. And that's when Miss Cowie's going from a minimum up to the maximum. So if you were to look at the actual Ferris wheel, she's at a minimum and she's now traveling up. So she's about this high from the ground. So in the next part, we are asked to find 2 times that Miss Cowie is 50 meters high. So that 2 times will tell us we're going to be solving a trig equation. So this time we know the height and we want to find the time. So we are going to substitute in the height in for h. So we get 50 is equal to 30 sine 90t plus 40. Because we need to rearrange and isolate for t, we use the opposite steps of BEDMAS, so Sam and Deb, whereas in part A, we did use BEDMAS because we were substituting in for t and simplifying. So we want to get rid of anything added or subtracted, so we're going to get rid of that plus 40, and to do that, we subtract 40 from both sides. So we have 10 on the left side equals 30 sine 90t. Then we want to get rid of anything multiplied divided, so get rid of that 30. So we're going to divide 30 by both sides. 10 divided by 30 is 1/3, or 0.333 repeating. If you're going to use decimals, carry a lot of decimals, only round at the end. So that is equal to sine 90t. So if you notice, this is now a trig function. We have to get rid of that sign. To do that, we have a positive ratio of 1/3. So we're going to use CAST and we can now find more than one solution. So remember, when solving trig equations, there's multiple solutions. We're only asked to find 2, so we're only going to go around the unit circle once. So this is a sine ratio. Sine is positive where A, all ratios are positive in A, and sine is positive in quadrant 2 where S is. So we're going to draw a solution here and here, and we are going to solve sine theta equals 1/3. And we get 19.5 is the reference angle. So that's the angle in here and the angle in here. Because the ratio is positive, 19.5 is a solution for theta. And then the other solution, our second solution, is 180 minus 19.5, which is 160.5. So going back to this equation, 1/3 equals sine 90t, we just took the inverse of sine of 1/3. And we found that 2 angles give that ratio of 1/3, at 19.5 and 160.5. So now we are going to sub back in and we want to find t. So the angle 19.5 is equal to 90t and 160.5 will set equal to 90t. So the first equation, 90t is equal to your first angle. Divide both sides by 90 to isolate for t. And when you do that, you get t equals 0.22. And then the second equation, 90t, t equals 160.5. Again, divide both sides by 90, and you get t equals 1.78. So that means Miss Cowie is 50 meters above the ground at 0.22 minutes and again at 1.78 minutes. So let's just look at what that means in terms of the graph and the Ferris wheel. So at 50 meters, we can just draw a line there. We can see where Miss Cowie's first at 50 meters above the ground, and that looks to be about 0.22, so that first solution looks good. And then the second time Miss Cowie is at 50 meters is just before 2, so that second solution of 1.78 makes sense. But then she goes down to a minimum, and then she comes back up. So on our curve, we can see that she hits 50 meters at least 2 more times if the ride lasts at least 7 minutes. So looking at the Ferris wheel, Miss Cowie would be 50 meters, it's above the midline, above the ground. First from the midline up, so about here, and then, so here's the midline where they start tracking Miss Cowie. She's 50 meters just above the midline. She goes up to the maximum and then comes back down to 50 meters, about there. We can actually find the next 2 times Miss Cowie is at 50 meters without solving a trig equation. We could do it that way, but what's easier is knowing the period. So every 4 minutes, Miss Cowie repeats. So at 0.22 minutes, 4 minutes later, she's going to be in that same spot. So 0.22 plus 4 is 4.22 minutes. And then 1.78 plus that period of 4, she's going to be in that new position. So that would be 5.78 minutes, which looks to be about right. So if you want to find that position in the next cycle, you just add the period. What's also worth noting is we know that maximum occurs at 1 minute. Miss Cowie is 50 meters above the ground at 1.78 minutes. So that is 0.78 minutes after the maximum. She's also at 50 meters, 0.78 minutes before the maximum, because 1 minus 0.22 is again 0.78. And that would be true from over here, and I've written that in pencil there. So you can see from the maximum here at 5 minutes, 0.78 after, she would be at 50 meters, and 0.78 before, she would be at 50 meters. So looking at the Ferris wheel, if this is the maximum, it takes 0.78 minutes, to go from 50 meters to the maximum 70 meters, and then another 0.78 minutes to go back down because the Ferris wheel travels at the same speed. And then from this point, it takes 4 minutes to rotate and get back to that point. And again, from this point, it takes 4 minutes to get back to that point. So a lot of these questions do require common sense. So just make sure you really are thinking about the graph and how it relates to this scenario.